Hello and welcome to lesson 4. I had some questions about lesson 4, question 4. And specifically, I'm going to look at question B. What happens here when we have an angle of 115 degrees? This is where the geometric method becomes very, I'll call it tricky or unstable, for lack of a better word. And I'll explain the why really quick here. So if we were to arrange it, finding the sum of the two vectors, we would say vector u goes across the horizontal. Vector v, the angle between them, is 115 degrees. So that means that, I'll move my vector over. Vector v actually is over here. So there's the 115 degrees. All right. So if I was to do the vector addition, that's what it's asking for, u plus v. So I would draw vector u this direction, and then vector v is going to be over here because I've got to maintain that angle of 115, and the internal angle then becomes 65 degrees. So from that, you can definitely go ahead and determine your resultant. So the resultant would be right here. That would give you your resultant, but you'll notice right here that this angle here, and I'll call it theta, it's going to be an obtuse angle. All right, it's an obtuse angle. And what does that mean? That means that when you go to do sine law to find that angle, remember that sine law will produce two answers. So we have that situation where there's two possible triangles. You could have triangle number 1 that looks like this, or triangle number 2 that looks like this. Now, when you use sine law, this is the one that sine law reports immediately, and this one is the one in this case that we actually want. So that means that you need to know your rules for sine law when you have obtuse angles. So this is one of my arguments for this situation where algebraic method is much, much better. And if you've tried these questions already, you'll find that answer number B, they're actually incorrect in their answer there. So if I was to set this up, I would do it with the algebraic method. It just makes it a lot cleaner to work with. So I'd have vector u down the x-axis. Vector v is going to be over here at an angle of 65 degrees because, again, they're 115 degrees apart. I know that u will look like this. So the magnitude's 3i. There's no angle to worry about, plus 0j. My v vector, it is negative x-axis, positive y-axis. So I would end up with negative 10 cos 65i plus 10 sine 65j. And if you use that algebraic method, you never, ever, ever run into this situation here with an obtuse angle and the sine law, because the algebraic method just adds the components together and gives you a right angle triangle as the resultant. So just to work that through so you know what the right answer is, then we have 3 minus 10 cos 65. So we get negative 1.2i and 10 sine 65 plus 9.1j. So there is the resultant, the magnitude of our resultant, negative 1.2 squared, 9.1 squared. So that would give us a grand total of, here are the answer, 9.2. I think they have like 11 or something for an answer for the magnitude. It's actually going to be 9.2. And the angle, tan inverse, 9.1 over 1.2. Again, I don't need to put the negatives in because I know I want my angle to be between 0 and 90 because I know which direction it's already facing. So tan inverse of 9.1 divided by 1.2. We get an answer of 82 degrees. So therefore, for this particular question, the resultant is 9.2 units. And the direction It's a negative, so I'm heading west. 82 degrees, it's a positive, so it's heading north. So that should be the correct answer with that. So algebraic method, you never run into those obtuse angles that cause us problems because it doesn't take into account, we don't use sine law. So when you use that sine law and you have an obtuse angle, you're going to have to recall your grade 11 skills on determining the two possible solutions. So keep that in mind when you're working your way through.